All right, this is section 4.3, and we're going to do kind of just some old school SOHCAHTOA. So this lesson should feel very familiar if you've done SOHCAHTOA in the past. So first off, we're just going to talk about how to operate our calculator. First up is the sign of 62, and this is the sign of 62 degrees. And so you want to make sure that you are in degree mode. And you find degree mode on your calculator by hitting the mode button right here. So right now I happen to be in radian mode. So I need to come down 3 lines, go over, hit enter, and then it highlights degree. So now I'm in degree mode. I can literally just hit, here's the sign button, and then 62 degrees. So the sign of 62 is 0.8829, we'll say, which is really just saying what is the y value at 62 degrees. So if you thought about your unit circle, 62 degrees is like, you know, right there. And it's just saying how high would you have gone up. We know that all the way up is 1, so if I went over like I was plotting a point and then up, totally makes sense that it'd be about 0.8, because that's super close to almost being up at 1. Next, I've got cosecant at 5. Now, we have talked about these being the reciprocal functions. They are not the inverse functions, which you also have a button for. So make sure that you just pay attention that this is cosecant. So any of the 3 reciprocal functions mean that I'm going to be doing 1 over and then its partner function of sine. This is not the same as, this is what kids will do a lot. They will do the sine of 1 over 5. Remember that this is an angle, and we need to find the value of that angle. We aren't going to change the angle. So if this angle, just to speak a language that you understand, like if it was 30 degrees, we still want to do the sine of 30. We don't want to do the sine of 1 over 30 degrees. We don't want to change the angle measure. We just want to do 1 over that value. So when you're doing one of these reciprocal functions, make sure that you are doing 1 divided by and then the trig function, so sine of 5. The other thing we have to catch on this problem is there is no degrees sign, which means that you need to switch over and be in radian for this one. And you get about negative 1.04. So a couple of things, make sure that you're using the right reciprocal trig function. Make sure that you're doing 1 over that entire value. Also, if you're not in a degrees, if you don't have a degree symbol, make sure that you are in radian mode. So as a quick recap, these first 3 trig functions, this is where you have theta and you are finding a side. These guys are reciprocal functions, so these are all the flips. This is 1 over sine, this is 1 over cos, this is 1 over tan. These are the flips. They don't actually find you sides or angles, okay, so that's not why we use them. These 3 are the inverse functions. We'll talk more at the end of this unit about how they work, how they came to be, but for right now, we're just using our knowledge from geometry, which is that they find angles. So this is where you have sides, and these help you find a theta. And they are the other little button on your calculator. So you can see your sine -1, cosine -1, tangent -1. These guys don't even have a button on your calculator. So you have to do 1 over and then whatever the matching trig function is. So let's just try a couple from geometry. So first you want to identify hypotenuse. That's the 20. Then we want to look from our angle. What else do we have? We have the opposite. And this is the adjacent, but since adjacent doesn't have anything, that we are going to use the O and the H. So we're going to set up for sine, since O and H are sine's function, and we're going to go sine of, and afterwards is always the angle measure. Then you are going to do the opposite, which is y, over hypotenuse, which is 20. I'm just going to put that over a 1. We don't usually write it because we, kind of get lazy. And then we're going to cross multiply. So 1 times y is y, and then 20 times sine of 56 is what we're going to type in our calculator. I do find it to be a little bit safer to put the 20 in front. When kids put the 20 after the 56, sometimes your calculator will do it wrong. Sorry, I'm trying to turn my room lights back on. Because of how you have parentheses in your calculator. So if you type in sine of 56 and you don't close that parenthesis off before you hit times 20, that's going to be incorrect. So I just find it to be safer to put the 20 in front, then I don't have to worry about that parenthesis. Oops. Immediately knew I was wrong because I was still in radian mode. There's no way the length of this side is -10. So switch the mode. Enter it again. We got 16.58. That makes way more sense in terms of my problem. If that's 20, one of my sides has just got to be less than 20. Next up, we're going to, again, identify hypotenuse. From the angle, this would be opposite. This would be adjacent. I don't have anything over here, so I'm not going to use that. I have A and H. That means cosine. I don't have the angle this time, so I'm just going to put my placeholder there, my variable. And then adjacent over hypotenuse is 6/11. In order to solve for theta, we have to get rid of the cosine. The way that you do that correctly is to inverse it. And sorry, I have to squeeze it in here. Cosine inverse this side as well. You have to, if you inverse one side, you get inverse the other. So that's how they cancel. And then I have inverse of 6/11. And now that is just what I get to type in my calculator. So cosine inverse 6 divided by 11, boom, 56.94. That's a degree measure, so make sure you put a degree symbol on it. Last one, hypotenuse across from the angle is opposite and adjacent. I didn't have anything on H, so I'm not going to use it. O and A means I'm doing tangent. 32 equals opposite over adjacent. This time I've got 6 times 1, and then this side I've got x and then tan 32. So if I was solving for x, I would need to divide by tan 32. So x equals 6 divided by tan, 32. And get about 9.6. Now we're just going to do a few word problems. Same thing. We're going to draw triangles for each of these and then just do our solving. So a surveyor is standing 50 feet from the base of a tree. 50 feet, little guy. The surveyor measures the angle of elevation to the top of the tree. So angle of elevation starts at the horizon and goes upward. And they measured that one to be 71.5. Looks good. We are hoping the tree is 90 degrees to the ground. We know that that's probably not actually legitimate, but let's pretend. And then we are supposed to figure out how tall the tree is. So I've got my angle. Here's my hypotenuse. Here's my opposite, adjacent. Hypotenuse didn't give me anything, so I'm going to be doing a tangent of 71.5 equals x over 50. So I'm going to cross multiply these two. Excuse me. 50 tan 71.5. 50 tan 71.5. Looks like I got about 149 for tree. That's a big tree. 0.43 and put feet on there. Sorry, squeeze it in. There you go. Next up, I've got angle of elevation to the top of LSHS. I would like to find it if you're standing 100 feet from the 40-foot building. So here I am standing. Here's the building. I'm standing 100 feet away. I'm saying wherever I'm standing, it's only 40 feet to the top, and I would like to know the angle of elevation. So I've got hypotenuse, opposite, adjacent, nothing there. So we're doing a tangent. Don't know my angle equals 40 over 100. In order to get theta by itself, I got to get rid of the tangent, which means I am inversing. Then we just have to type that one in. So 40 divided by 100. So 21.8. Remember, you found an angle, so get a degrees symbol on there. Next up, what is the angle of declination? That's different from an airplane in flight that is 7,000 feet above the ground and 20,000 feet from the airport. Here's my airplane because I cannot draw those. We are 7,000 feet in the air. And over here is the, let's put a P for plane, and we'll put A for airport. And then over to the airport. You could make an argument either way as to whether or not we are ground feet, like physical ground feet away from the airport, or are we diagonal feet away from the airport. I'm going to put it on the diagonal. I mean, it doesn't really matter. We're just going to do the problem for practice, but again, you can make the argument either way. I'm just going to pick one so we all do it the same. So we're looking for the angle of declination. What's interesting is declination starts from the horizon and goes down. So angle of elevation up here started from the horizon and went up. Declination starts and goes down. And that angle right there is not inside of our triangle. So when we're using 7,000 and 20,000, I need angles that are in here. So one way you can do it is by, if you remember in geometry, parallel lines, alternate interior equals. So this angle appears the same as this one down here. You could also, I'm just going to extend that a little bit. You could drop that down and make this triangle still 7,000, and you could just treat, and you could use it like that. Either way, the 20,000 is the hypotenuse and the 7,000 is the opposite. So we're going to do a sine 7,000 over 20,000, and you'll need to sine inverse in order to get rid of it. Oops, one more zero. And then sine inverse 7,000 and 20,000. So it looks like my angle is about 20.5 degrees. Last one says 200 feet away from the base of the football stadium, the angle of elevation to the bottom of the flagpoles is 40 and the top is 37. You need to switch those around. That is a typo by me. This should be 37. This should be 40. I can't have the bottom of the poles be a higher angle than the top. That doesn't make sense. So here's the football stadium. If you've never looked, there are flagpoles on top that have all of our conference competitors up there. And so I'm saying I'm standing 200 feet away. And the angle of elevation to the bottom of the flagpoles is 37. And then the angle of elevation to the top of the flagpoles is 40. But that means this whole angle is 40, not just this tiny wedge, the whole thing. So I'm actually going to draw two different triangles. I'm going to draw the first one that has the 37 there, the 200 there, and I'm looking for that. That's going to be to the top of the building. I'll put a B for building. Then I have the other one. Oh, I'm running out of ink. That's going to be 40, still 200, and I'm going, this is the building plus the flags, so that's everything. I'm going to do both of these problems, and then in order to figure out just the flags, I'll take the flags and subtract the building, and I'll just be left with the flag part. So this is going to be a tangent 37 equals b over 200. Come on, pen, last till the end of this. So this will be 200 tan 37, which is about 150.71. The other one will be tan of 40 equals flagpoles over 200. So again, 200 and tan of 40. That looks like it's 167. Sorry, I'm going to squeeze it in here because my pen's dying. And then I just subtract the two. So this is all the way to the top of the flags. That's the top of the building. If I subtract the two, I will find out how tall the flags are. And they look like they're about 17 feet tall, literally as my pen ran out. So there's just a review of SOHCAHTOA, some stuff from geometry about how to solve a triangle.